Today we are going to learn the numerical solution of ordinary differential equation using Euler's method. This Euler's method is used to solve the first order differential equation of the type dy by dx is equal to f of xy. This is figure number 1. This figure number 1 shows the curve formed by this differential equation dy by dx is equal to f of xy with step size h. Initially we have given x0 and y0, that is x as x0 and y as a y0. Using Euler's method, you have to find the value of y1 at x1. This x1 is calculated as x1 is equal to this x0 plus h. Therefore, using Euler's method, here we have to calculate this value of y1 for x0, y0 at x1. Therefore, according to Euler's method, first draw a tangent at point P, whose coordinates are x0, y0. This is the tangent drawn at point P, which intersect this x1 line at point Q, whose coordinates are x1, y1. This is our actual Q dash with coordinate x1, y1. That is, this is the y1, actual value of y1. Here we have to find this value y1. Now draw a line parallel to x-axis passing through P. Now this parallel line intersect the x1 q dash at point R. Now from the geometry of this figure, this total distance is y1, this is y0, therefore this QR is equal to this y1 minus y0, and this tangent PQ form an angle theta with this parallel line PR. Therefore, considering triangle PQR having an angle theta, here tan theta is equal to QR divided by PR. Here QR is equal to y1 minus y0 and PR is equal to h. But we know that tan theta is equal to dy by dx is equal to f of xy at point P, and coordinates of point P are x0, y0. Therefore it becomes f of x0, y0. Therefore tan theta is equal to f of x0, y0. Therefore this equation becomes f of x0, y0 is equal to y1 minus y0 upon h. After simplification, this y1 is equal to y0 plus h of x0, y0. This is called as Euler's equation, which is used to solve the first order differential equation of the type dy by dx is equal to f of x, y. So important thing is, it is applicable for a single step. This formula is applicable for single step. This is single step. For more than one iteration or a number of steps, you have to find y2. y2 is equal to, then formula becomes y1 plus h of x1, y1. Or we can use equation number 1 for the next iteration, but you have to replace the value of x0 by x1 and y0 by y1 for the next iteration. Then for the next iteration, x0 by x2, y0 by y2. Then for next iteration, x0 by x3, y0 by y3. Likewise, you have to just replace the values of x0 and y0. You can use the same formula for the number of iterations. Now consider an example on Euler's method. The differential equation is given dy by dx is equal to x minus y square. For the given boundary conditions, x is equal to 0, y is equal to 1. Find the value of y at x is equal to 4. Take step size h is equal to 1. Now given The differential equation is given dy by dx is equal to x minus y square. For the given boundary condition x is equal to 0, it means that initial value of x as a x0 is equal to 0 and y is equal to 1, that is initial value of y is equal to y0 is equal to 1. That is this x0 is 0 and this y0 is 1. Step size is h, which is equal to 1. You have to find the value of yg when x is equal to xg is equal to 4. That is final limit of x is equal to 4. That is x1, x2, x3, x4. Here you have to find this value y4, that is yg when xg is equal to 4. Now for that, first step is to calculate the step size. H is equal to xg minus x0 divided by h. Xg is equal to 4 minus initial limit 0 divided by 1 is equal to 4. Now iteration number 1. For iteration number 1, initial value of x0 is equal to 0, y0 is equal to 1. Now x1 is equal to this value x1. x1 is equal to x0 plus h. x0 plus h, that is 0 plus 1 is equal to 1. Here you have to find the value of this y1 for this x0, y0 at x1, at this x1. Therefore, using Euler's formula, yz is equal to, that is y1 is equal to y0 plus h f of x0, y0. Here y0 is equal to 1 plus step size 1 and this function f of x0, y0 function is given x minus y square. Therefore, f of x0 minus y0 square, put the value, the answer is minus 1. Therefore, the value of function is minus 1. Therefore, finally you will get yg, that is y1 is equal to 0. After first iteration, when x0 is equal to 0, y0 is equal to 1, x1 is equal to 1, h is 1, value of y1 is equal to 0. That is when x1 is equal to 1, y1 is equal to 0. Now for second iteration, as we are going to use the same formula, therefore here we have to replace the value of x0 by x1. Here x0 by x1, therefore x0 becomes 1 as x1 is equal to 1. And y0 by y1, therefore as y1 is equal to 0, y0 becomes 0. Now new value of x1 is equal to x0 plus h, that is this value. This become, as we replace x0 by x1, this becomes x0, this becomes y0. Therefore this value x1 is equal to x0 plus h. x0 is 1, h is 1, 1 plus 1 is equal to 2. Use the same formula. Therefore yz is equal to y0 plus h of x0, y0. y0 is 0 plus h is 1 into this function, that is x minus y square, that is x0 minus y0 square. x0 is 1 minus y0 is 0. The equation, put the value in this equation, you will get yg is equal to 1. That is after second iteration, the value of yg is equal to 1, that is y2. Now iteration number 3. For iteration number 3, we have to replace x0 by x2. That is this x2 is equal to 2 and y0 by y2, that is y2 is equal to 1, which are the values obtained in iteration number 2. Therefore this x0 becomes 2 and y0 is equal to 1. New value of x1 is equal to x0 plus h. x0 is 2 plus 1 is equal to 3. Again using Euler's formula. For iteration number 3, we are going to calculate y3. That is y3 is equal to yg is equal to our formula y0 plus h of x0, y0. y0 is 1 plus step size 1. Our function is x minus y square. Therefore 2 minus 1 square. x0 is 2 and y0 is 1 square. Therefore yg is equal to 2. That is this is the value for y3. That is when x3 is equal to 3, y3 is equal to Now for iteration number 4, replace x0 by x3, that is x0 becomes 3, and y0 by y3, that is y3 is equal to 2, therefore y0 becomes 2. Now calculate new x1. x1 is equal to again x0 plus h. x0 is 3 and h is 1, therefore 3 plus 1 is equal to 4. Now x1 is equal to 4, that is the final value of xg, which is equal to 4 for iteration number 4. Again using Euler's formula, iteration number 4 will give you the value y4 value, which is equal to yg equal to y0 plus h of x0 y0. y0 is equal to 2 plus h is 1 into 3 minus 2 square. Therefore yg is equal to y4 is equal to minus 3. After fourth iteration, the value of y4, that is yg, is equal to minus 3 when xg is equal to 4. Here for this case, the initial value of x0 is equal to 0 and final value, that is xn or xg, is equal to 4 with step size h is equal to 1. It means that Euler's formula is applicable for 4 number of iterations. Therefore after fourth iteration, the value of y4 or yg is equal to minus 3.